All right, welcome to The Explainer. Today, we're jumping into a real cosmic whodunit, a mystery that's been baffling scientists for over 100 years, and it stars one of the most mind-bendingly extreme objects we've ever found in the universe. So just try to picture this. You're looking out into the absolute deepest parts of space, 4 billion light years away, and you see this cosmic giant that's just blinking. And not randomly, but with a weirdly predictable rhythm. This thing, OJ-287, has been sending us these bizarre signals for as long as we've had the ability to look. Which, leads to the big question, the one astronomers have been wrestling with for about 150 years now. What in the universe could possibly have enough power to make an entire galactic core blink on and off like a cosmic lighthouse? Okay, so like with any good cold case, you gotta start with the primary person of interest. In our story, that's a type of object called a blazar. But as you're about to find out, OJ-288 is no ordinary blazar. Not even close. So what exactly is a blazar? Well, think of a supermassive black hole just sitting at the heart of a galaxy. And it's just devouring enormous amounts of gas and dust. This whole process is so incredibly violent that it shoots out these massive jets of particles at almost the speed of light. And a blazar? That's what we see when one of those jets happens to be aimed almost directly at us. Yeah, it's pretty much like staring right down the barrel of a cosmic cannon. And get this isn't some new puzzle we just stumbled upon. Scientists have been tracking OJ-287's strange flickering for a century and a half. And over time, they noticed two distinct rhythms. There's a really long 60-year cycle, but also a much shorter repeating 12-year cycle. And it's that 12-year pulse that really became the central clue in this whole mystery. You see, having a clockwork 12-year pulse coming from something as chaotic as a blazar, it just didn't make any sense. To explain it, astronomers had to get creative. They needed a theory that was, frankly, pretty radical. And the theory they came up with was this. What if it's not one monster at the center of all this chaos? What if it's two? A pair of supermassive black holes trapped in this epic gravitational dance with each other. And when we say supermassive, that word is a wild understatement here. The bigger of the two black holes in this system is estimated to be 18.35 billion times the mass of our own sun. That number is so big, it's almost impossible to even wrap your head around without some context. So let's try to put that into perspective. The black hole at the center of our own galaxy, the Milky Way, it's called Sagittarius A star. It's a beast at about 4 million times the mass of the sun. But the main black hole in OJ-287, it's over 4,000 times bigger than our own. It is an absolute monster of unimaginable size. So here's how this two-monster theory perfectly explains that 12-year cycle. You have a smaller black hole, which is still a giant at 150 million times the mass of the sun, and it's in this long oval-shaped orbit around the main one. Every 12 years, that orbit makes it plunge directly through the huge, superheated disk of matter swirling around the bigger black hole. That collision, it creates this absolutely titanic burst of energy, and that's the blink we see all the way back here on Earth. Now, it was a brilliant theory. I mean, it explained everything perfectly. But for a long time, that's all it was, a theory. To really prove it, astronomers needed evidence. They needed a cosmic smoking gun. And when they finally got it, the excitement in the scientific community was just off the charts. The lead astronomer, Ophelia Triano, she put it really simply. She just said that what they were seeing, the level of detail, they had never observed anything like it before. So how in the world did they get an image like that? Well, basically, they built a telescope bigger than planet Earth. They linked up 10 radio telescopes on the ground with one orbiting up in space. And by combining their power, they created a virtual lens that was 5 times wider than our entire planet. This gave them a view into the heart of OJ-287 that was sharper than anything ever achieved before. And with this incredible new planet-sized eye on the sky, they saw it. The smoking gun. The jet of particles that was blasting out of that main black hole. It wasn't straight. It was crooked. It was seriously bent right near its source. And there it was, the why. I mean, think about it. What could possibly be powerful enough to bend a jet of matter moving at nearly the speed of light? Only one thing: the immense gravitational pull of that second orbiting black hole. As it swings around the main one, its gravity literally yanks on the base of that jet, causing it to bend and wobble. This crooked jet is the physical proof. It's the footprint of that second monster, confirming it's really there. The observations also came back with something else that was just wild. They clocked parts of the jet at an apparent temperature of 10 trillion degrees Celsius. Now, that sounds impossible, right? Because, well, it is. It's a fascinating illusion we call relativistic beaming. It's kind of a cosmic Doppler effect. When particles are rushing towards us at these incredible speeds, it makes them appear fantastically, unbelievably hotter and brighter than they actually are. So, boom. Case cracked. The mystery of the blinking Blazar is solved. But you know, confirming this two-monster theory does way more than just close a cold case. It actually opens up an entirely new laboratory for us to study the universe. Yeah, OJ-287 isn't just a weird oddity anymore. It's now one of our best real-life laboratories for understanding how supermassive black holes actually merge. By watching this cosmic dance happen in slow motion, we can test our theories about gravity and learn about the ripples in space-time, gravitational waves, that these systems create long before their final cataclysmic collision. See, our current gravitational wave detectors here on Earth, they can't pick up the super long, slow waves coming from a system as huge as this one. But future space-based observatories, like the LISA mission, are being designed for exactly this purpose. When it finally launches in the 2030s, OJ-287 is going to be one of its absolute prime targets. So while the case of the blinking Blazar might be closed, the real investigation has just begun. This whole system is a ticking cosmic clock, counting down to one of the most powerful events the universe can produce. And by watching its dance, we get a sneak preview. It leaves you wondering, what other secrets is this clock going to reveal before it finally, eventually,